All right. Good morning, everybody. So welcome to the second session of AI for All webinar series. And today with me, I have Kevin Galloway, system admin at Research Computing System. And so today's topic is Linux Foundation, and it's a beginner's intro to command line. In the next 1.5 hours, Kevin will talk about that. And just for your information, we are recording this session also, and that is available at uaf-data-ai-lab website. And where you can find everything in here. So the web address is cs.uaf.edu/data-ai-lab. And if you go to this AI for All template, you can see all the materials and everything is posted there. So if you want to know about our speaker, you can do like this. So today's speaker is Kevin. So Kevin, he has been with Research Computing System for almost 9 years, and currently as a Linux and HPC analyst. He received his bachelor's and master's degrees in computer science from UAF. His work focuses on system administering HPC clusters and helping researchers and access and utilize high-performance computing. And all the materials that Kevin will share will be available in the same website in this place. So Kevin, without much delay, I am stopping sharing. So please feel free to share your thing.
Right.
And let's start.
Requests. Okay, there we go. I'll share the whole desktop and your full screen. Hi. So this talk is going to be just a kind of a beginner's intro to the Linux command line. It's kind of an eat your vegetables sort of talk, just because once you jump onto these HPC systems, you're typically using the Linux command line. And I'll go over a few reasons why that's the case. So as a brief introduction, as Dr. Das mentioned, I work for Research Computing Systems. We handle a lot of the cyber infrastructure for mainly the Geophysical Institute, but also kind of the research side of UA if they want to make use of our services. Most important to this AI for All initiative, we also administer the Chinook HPC High Performance Computing Cluster. So I'm going to talk a little bit about why we choose Linux, talk about kind of the directory structure and like file layout on Linux, and then talk about how you can get system information from the command line, kind of file, directory, copying, removing, deleting, those sorts of operations. Talk about environment variables, and how they're kind of a powerful tool that you can use to run your programs on an HPC system, and then touch briefly on what's called shell scripting, the kind of nuts and bolts of how you can repeat your workflows and run a bunch of commands kind of constantly rather than having to like manually type out what you want to do. So first off, what is Linux? It's what's called a Unix-like operating system. Unix was an operating system developed a while ago, and then a bunch of researchers kind of liked how it was sort of laid out and made their operating systems that were pretty similar to it. Multiple distributions are available of Linux. You might have heard of like Ubuntu, Red Hat, Fedora, Linux Mint, Arch Linux. There's a whole lot of those. All the different distributions kind of have their own focuses, their kind of own pros and cons. Some try to be a little bit more user-friendly. Others are built more for kind of a server environment. But there's a whole bunch of distributions out there. You can probably find one that you'd like. And they're also used on like embedded systems, like stuff like Raspberry Pis, robotics, stuff like that, all the way up to, 100 node, 1,000 node HPC clusters. We at RCS typically use Red Hat derived systems. Usually the open source version Rocky Linux is what we're running on Chinook. Most distributions are free and open source. That usually means you can download it, install it. And if you really like messing with code, programming, or want to learn about that, you could even write your either contribute to those projects or kind of spin off your own distribution. And then also there's always a lot of software and tools built for Linux, for both kind of software development and also for a lot of research. All right, so now we get into why do we want to use Linux in the command line. If you come from a kind of traditional Windows background, or if your computing is mostly on your phone, you're kind of used to doing things in a graphical user interface. And while that's in a lot of ways easier to use, it does come with some downsides. Um, but first off, using the command line can be very flexible. You can use it interactively, so you're kind of hands-on keyboard, being able to do stuff as you go. But you can also create little scripts to run a bunch of commands that you have to run constantly. Um, it's often used in HPC environments. This is usually because you don't really get direct access to an HPC cluster. You're not going to be on the compute nodes, logged in, being able to do whatever you want. Usually you kind of are a few steps removed from that. So being able to access it through the command line or through submitting scripts is kind of the way you have to do it in the HPC world. Another thing, as I mentioned, the phone, Windows, you do stuff in kind of this graphical user interface. Doing it like that is also, in a lot of ways, time inefficient. You're having to click through a bunch of menus, drag and drop, um, icons to places, do things like that. And so if you had to do that when you're running like thousands of analyses, um, that would take a lot of time if you have to like be tethered to your computer to do that. Linux is also very developer friendly, like picking up shared libraries, being able to find the binaries that you need, the executables, the programs that you need. It's very flexible. You can do that in a lot of easy ways. Whereas sometimes messing with that in, say, like Windows can be difficult because you have to know how to set your environment variables there, find the application in whatever directory it was installed in. So command line and Linux can be a little bit more flexible in that way. And then just again, using the command line makes repeating commands, programs, runs much, much easier. Again, if you had to click through a GUI to run thousands of, like run a program to analyze thousands of sample files, and you had to do it like individually, it would take a lot of time and you'd probably be bored out of your mind. If you've never accessed a terminal or command line interface, if you're on a Linux machine, there's usually a terminal program that you can find to access. On Mac, which is also kind of a Unix-like file system under the hood. If you go to Finders, Utilities, and then Terminal, you'll have a terminal that you can mess with. It's pretty similar to Linux or a lot of the Linux distributions, but there might be a couple of things that are a little different. It's derived from a different kind of operating system than most Linux distributions. And if you're on a Windows machine, Windows has come out with their Windows subsystem for Linux, which basically just installs like an Ubuntu kernel and Ubuntu kind of operating system on your Windows install, and it'll be exactly like using Linux there. To start off with, I'm going to talk a little bit about the Unix shell. This is how you interact with the command line. It's basically a command interpreter, which means that there's kind of a couple of unique things each of these shells can do, like how you set environment variables, how you can configure your terminal or your shell, like they might have different options. Um, there's a whole bunch of these. Bash, C shell, K shell, Z shell, a whole bunch of it. RCS tends to stick with Bash, the born again shell. That's what all these examples are going to be in. So if you're using something like C shell or Z shell, some of these examples might be slightly different. You might have to look up kind of like how to set an environment variable in C shell versus Bash. If you're on a Mac, it uses Z shell, which is mostly compatible with Bash, but it has a couple of differences, so it might not be completely one-to-one. Finally, most shells can be customized using RC files or profile files. So for Bash, it's the Bash RC, Bash profile, ZSH RC on Macs. I think it's like CSH RC for C shell. And this allows you to either like alias commands as soon as you log in, so you don't have to like set that up manually. It allows you to tweak how long what's called a history file is. Most of these shells keep track of some number of commands that you've run in the past, which can be really useful if you've like had to run some complicated command with like a bunch of flags, months ago, and you're trying to remember what it is. You might be able to find it in your history file, and it just kind of lets you do all sorts of stuff for your customization, which can be useful. And just a couple of tips before we really get started. Most commands and executables in Linux follow this kind of command, pass it some flags, really just some options, and then a target, like a file name or something like that. They follow this sort of structure. So for example, if you're trying to do like list out a list of files in a directory, use the ls command. So you could do like ls-l, which means long, which just gives you more information, and then the directory that you want to list. Another thing, most Linux distributions have the man command manual, and you can do this to find information about most commands. So if you do like man cd, it'll give you all the options for the cd command. Should have mentioned this at the start. Basically, the way this workshop is going to go, I'm going to present all the slides, and then we'll go on for some more hands-on examples at the end. So I didn't want to have to deal with switching from the presentation to the terminal and getting a little confused there. Most commands usually have a -h or -- help flag as well. This usually just gives you information for how to run the command directly in your terminal. And also, for a lot of programs built on Linux, they follow this kind of convention as well. They sometimes have a man page that you can use, and a lot of the times they'll have this -h or -- help flag. If you're coming from the Windows world, one thing to be aware of is paths, directories on Linux use the /, not the \. It can make copying files from Windows to Linux, or usually copying code from Windows to Linux, kind of run into some issues. You might have to change which way your slashes are when you're referring to directories. Excuse me. And then finally, if you're on a shared system, like one of our HPC clusters, you won't have access to what's called sudo. Sudo is how you can gain administrative privileges to like install software system-wide, add users, do stuff like that. If you're on your home machine, you can definitely set up sudo access for your command for your user and yourself. On shared system, what's going to happen if you try to run a sudo command, like you're just following a tutorial, and they tell you to install some software. Usually the system administrator will be flagged. They'll see that someone tried to do that, and they'll have to determine whether it was an honest mistake or if someone is trying to do something a little nefarious. So if you're on Chinook, don't use the sudo command. And then there's just a couple other kind of handy bash terminal tips and tricks. Usually, if you're on a Linux system, hitting the tab command will try to autocomplete. So if you say you remember like the first half of a command, like, I don't know, MK is somehow involved in the make directory command, you can do like MK and hit tab a bunch of times and it'll show you all your options. Or if you have a whole list of files in a directory and you don't quite remember like the exact structure, you can put in like the start of some files and hit tab. And it'll show you your options. Hitting Control+R will search your history for commands. This can be really useful if you're running a bunch of stuff and you knew that you ran a command like 5 or 6 commands ago and you just don't want to have to type it in again. You can like hit Control+R, start typing in the command, and it should find the last time you ran it. Control-E, when you're in a terminal, will go to the end of the line that you're on. That can be useful if you need to like just replace a file name or something like that. And Control-A goes to the start of a line. Say you're running a command that has basically the exact same flags as something else. You can go to the base and sub in another command. You can set it up on your Mac terminal and most other kind of terminals. If you do Alt or Option on a Mac plus F, will move forward a word in your command. So that can be useful if you have like a flag in the middle of your huge line that you need to change. and Option B or Alt B moves back a word. And if you just need to clear everything before a cursor, like, I don't know, you're using the same file name, but doing it using a different command on it, you can hit Control U and that will delete everything before your cursor. So now we can actually start talking a little bit about how Linux is sort of laid out, how it kind of works. So the directory structure of Unix, Linux, a lot of these file systems is kind of described as of a tree. You have your slash, which is your like base directory, your kind of starting place is what's called the root. And then each directory you have kind of moves down to other branches. And then each kind of subdirectory and root is separated by these forward slashes, like we mentioned before. And then it kind of branches out the directories of directories of directories. Users typically have what's called a home directory. It's their starting spot where they log in when they log into a Linux system. A lot of your config files are here. A lot of directories for like SSHing, connecting to systems, or configurations for your user account can be in your home directory and it's kind of expected to be there. The location of a directory is called the path. Um, and there's kind of two types, the absolute path and the relative path. Absolute is kind of, and I'll show you an example of this, is the path to where your directory is starting from root. So like slash home slash your username would be an absolute path. Relative just starts from your current location. So if you're already in slash home, you could do like CD username to get into it. Some common commands for navigation on Linux. One is the pwd command, which is the current working directory. This is like what directory you're currently in, where you are. ls lists everything in your directory, kind of what's around me, what files, what directories are in this current directory. And then also there's the CD, change directory. I need to go to a different directory. Doing CD directory moves you into that directory. That can be an absolute path or a relative path. Typing just CD or CD tilde forward slash can return you to your home directory. That can be useful if you've like deep down in a bunch of subdirectories and need to start from the beginning again. And then CD dot dot moves you up one level, like to what's called the parent directory. And these can also be combined in a bunch of different ways. The next kind of section that's kind of useful is the getting information is kind of what I'm calling it. Again, we talked about the ls command. This lists files and directories in a location, either your current location or somewhere that you specify. You can pass it a bunch of options and flags to have it do a bunch of different things. Like the ls-a, for example, will show all files. Linux has something that's called hidden files, where if you put a dot in front of a file name, it just won't show up by default. These are usually used for like configuration files and things like that, or like configuration directories that you really don't want people to mess with unless they really know what they're doing. Yeah. You can also, like some of these other ones, will sort by time, descending, ascending, etc. The which command will tell you the location of like a file or executable that's in your path. We'll talk about the path a little bit later, but it's basically where your shell will look for commands and stuff like that. This can be useful if you have multiple versions of something installed and you're trying to figure out which one is actually being used. The less command will let you like view a file or output and kind of scroll back and forth in it. The cat command will display the contents of a file to standard output. This is really useful for like text-based stuff and like CSV files. You can cat a binary file, which will just print a bunch of gibberish to your screen and might mess up your shell. So if you've like compiled a program, you don't want to try to cat the compiled program for the most part. Kind of related to the cat command is head and tail, which will show like list lines at the start of a file or list lines at the end of a file. And then there's the grep command, which is incredibly useful if you're working with text-based um, files in general. This allows you to search through a file for, or multiple files for like a word, a number, anything you want inside of a file, you can search for it using grep. Um, I think you can even do it on like binary files as well if you really need to, if you're like looking for some strings or something in a compiled program. One thing you need to be aware of on Linux is permissions. Kind of by default, when you create files or directories on Linux, generally only your user is given access, your user and group are given access to that file. And usually, depending on how stuff is set up, your user gets what's called read, write, and execute permission. The group gets usually read and execute, and then other, it can kind of depend on how stuff is set up. Basically, what this means is if you have read permissions, you can open the file, view the contents of the file, but you can't do anything else with it. If you have write permission, you can edit that file, you can delete it, you can move it, um, and you can basically do whatever kind of editing to that file that you want. If you do have read access, you can copy the file, and then you can do whatever you want to the copied version, but you can't do anything to the original one. Finally, the execute permission means that if this thing isn't executable, like this is a program that's compiled, it's a script that you can run like a bash script. You can run it. You can actually execute it. The other thing the execute bit does, which can seem a little counterintuitive, is it needs to be set on directories to be able to access the directory. So if you have read and write access to like, I don't know, a data directory, but you don't have execute, you can't actually like cd into that directory or really access it. There's also this thing called the set group ID, set GID. This just is another kind of option you can set that says, hey, when I create this file, make it owned by my group and give it the proper permissions. Some other kind of file permissiony commands. There's the chown command, which will change the ownership of a file. Generally, you need administrator access for both for this command, but so if you do have like kind of administrator access or something, you can have someone else own the file if needed, which can be kind of useful if you're kind of working on like a group project or something and someone else needs to kind of either access the file, or if like you're moving on from your project and you want to make sure that the people who are remaining can still access it. The chgrp command, change group command, will let you change what group owns this file. This can be useful if you're a member of multiple groups, and then you can change the group ownership and have other people be able to access it. Finally, the chmod command allows you to actually change the permission. So you can, remove or add read-write access to yourself, to others, or to your group. One thing I did forget to mention is file permissions by default on Linux are user, group, and other. So user is what user has access to it, the owner of the file, what they can do to it. Group is whatever group owns it, what they can do to it. And then other is literally everybody else on the system. So messing around with the other permissions, be a little careful. You might accidentally give everybody like write access and then anyone can edit the file. There are other more complicated ways that you can manage file permissions, but that's not going to be covered in this talk. So with the chmod command, when you're changing these permissions, there's kind of two different ways of doing it. The original way was called this octal format. You would throw it a set of 3 numbers that meant like read, write, execute, depending on the number, or like just read and write. It all has to do with the bits of that number. Nowadays, there's what's called character flags, where you can just say, hey, give user read-write access, and that's how I recommend you do it going forward. The octal format, you kind of either have to study kind of how these are set up and then kind of learn what those numbers are, or memorize what each number means. Um, and that can get a little confusing and can be a bit much if you just want to get up and running on Linux. Um, Another thing, when you're running a lot of Linux commands in general have this -R flag, which usually means recursive, which means like do this command in this directory and all of its subdirectories. And then so if you need to change all the permissions in a directory and all the files underneath it, you throw out this -R flag. Also with chmod, there's -X. This one is really useful. Um, Basically, if you're like changing permissions in a whole bunch of files and you have like data files mixed up with files that should be executable, you throw it this -X flag, like -R recursive -X, and it will only set executable permission on files that already have another executable flag. So this is useful because then it will only change permissions on like your scripts or your compiled programs to make them executable, not all your text files. If you're working in a group and need to kind of change what your default permissions are when you create a file, you can use this umas command. Kind of unfortunately, it uses that octal number format, and it's a bitwise operation with it. So just as a quick example, 755 means give, read, write, execute. That's the 7. 55 is, if I remember correctly, read and possibly execute. If you want that your UMass to be that, it's 022, and you do this bitwise, or if you're in computer science or have any familiarity with bitwise operations, that's what it's doing under the hood, which means it can get a little complicated. Usually it's easier to just Google a UMass calculator to get the UMass that you want. But once you set that, any files you create afterwards will come out with that permission. And it's a little warning, adding group other permissions in your home directory can cause issues with particularly one of two things. One, just kind of security monitoring in general. Like some centers are very strict about kind of security of files and stuff, so it might trigger something in that. Or if you're using SSH or an SSH key to log in, so you can get this file, you create a set of keys that allow you to log into a system either without using a password or with the password you already put in. Changing, like if you add group or other permissions to your home directory, SSH can get cranky because it expects very strict permissions to make sure that like someone else can't put a key in your home directory and log in as you. Next set of commands are kind of what I'm calling file manipulation, copying a file, the CP command for moving a file, RM, or directory. If you're doing a copy or removal of a directory, you do have to pass it this recursive flag, this -R. Otherwise, it just doesn't know what to do because it doesn't understand that it needs to copy the directory over and all the files. There's this move command, which moves a file. This one's a little interesting because it doesn't actually move the data like physically on the system. It just kind of changes what's pointing to the data. The only time it will actually copy a file over is if you're moving across file systems, in which case basically what it's doing under the hood is a copy and then a deletion of the original data. In general, if you're copying stuff between file systems, we definitely recommend doing a copy, like an explicit copy, get it all copied over, and then just manually delete it yourself rather than using a move, just because if something happens in the middle of the move command, you don't know where it died, what got deleted, etc. You can use the mkdir makedir command to make a directory. And then if you're kind of wanting to transfer files from one machine to another, you can use this scp command, secure copy. to copy like a file from one machine, like one laptop to an HPC cluster, or you can use the rsync command, which will rsync, will keep two directories in sync with each other by copying files back and forth. The nice thing about rsync is if you do that, like if you're copying a large amount of data, and your copy dies in the middle of it, if you run the rsync again, it will kind of pick up approximately where it left off. Set a command, what I'm calling system information. You can run the top command to see what's currently running on your system in a text user interface. It can be useful just to kind of get an idea of what's going on literally at the moment. The PS commands will show what commands you're running. Currently, this is useful if you're using what's called background processes, which I'll talk about in a little bit. There's also a bunch of different flags here where you can technically see all the processes that are running on the system. You can also pass it a bunch of flags to get different information, like how much memory, how much CPU, etc., that a process is using. The df command will show you what file systems are available. This is kind of useful on shared systems, HPC systems, because you might have multiple file systems, and knowing what they are is pretty useful. And the du command will check your disk usage, both the files and directories, depending on what flags you pass it. Finally, there might be some quota commands depending on different file systems. So a lot of HPC centers set a quota on how much storage you have in various file systems. So there's a whole bunch of different quota commands that might come up. And then some commands for actually manipulating processes. So say you have a background process that's running, it's using up almost all your CPU, it's slowing everything down. You can kill it with the kill command, kill, type in the process ID number, and it should stop it. If you run command followed by an ampersand, it will run a process in a background. So this just allows you to run multiple instances of something or multiple programs all at the same time without either having to open up a bunch of different terminals or once you get onto a compute node or something like that, that is one way to achieve parallelism to kind of be able to run a bunch of stuff at the same time. And if you do the FG command, either if you only have one background process, just typing FG will bring that back to the foreground. If you have multiple, you do FG process ID number, and it will just start running in your terminal and take it over again. One thing that a lot of shells and Linux have are what's called environment variables. These are just variables you can set in your shell to refer to basically whatever you want. So like if you're running a bunch of analyses or a bunch of programs on a set of data that's all in the same directory, you can create an environment variable called like data_dir, and every time you type in $data_, it will sub in the directory that you set it as. Some environment variables have kind of special meaning. Your home directory, $ capital all caps home is your home directory, your usually cd home/username. The path is where it will look for binaries, scripts, executables. A lot of compiler or things to help you compile programs, make files, configure CMake will let you set stuff like the CC, FC, CPP environment variables, which point to where your compiler is, your C compiler, Fortran compiler, C++ compiler. LD library path is where your shared libraries are, and there's some other kind of important ones, but those are just kind of a smattering of some of the kind of special ones. If you're in Bash, to set an environment variable, you just do export variable name equals what you want that variable to be set to. And some of these can be important when you're actually running programs too. A lot of scripts or a lot of executables might expect some environment variables to be set. One of the common ones on our on Chinook is a license environment variable, just pointing out where a license file is. MATLAB, for example, sometimes needs to have this license variable set, otherwise it doesn't think it's licensed. The other part of this is you can use wildcards in your bash commands to search through things. These are separate topics, but merge them on the same slide. The question mark will just substitute a single letter for anything. So say you have a bunch of data files that are named after years and you only care about ones in the, I don't know, the 2020s. You could do like ls 202 question mark, and it will list out everything that starts with 202 and another character, another letter, another number. If you do a star, it will just sub in anything, any number of letters, any number of digits, characters, anything like that. And I'll show a couple of examples of wildcards because they can be pretty useful. One kind of powerful thing you can do in Linux on the command line is what's called input-output redirection. So because you're kind of in this command line shell, you can run a program and redirect the outputs to a file, for example, and then you can kind of save whatever your program spits out, and you can use that to like analyze, or sometimes that's just how you get your data into another format. One thing that Linux does have is multiple what they call input-output streams. Most things go to what's called standard out. That's just what's printed in your terminal, and that's really easy to redirect to a file. Standard input is usually how you input something into your commands, usually from the keyboard. That's kind of how that works out. And then there's what's called standard error, which is a little special. You just have to do a little bit of extra work if you wanted to like save the output of standard error into a file, or if you wanted to use other commands on the output of standard error. A lot of programs just expect stuff to come from standard output. Really, the only reason I bring this up is a lot of HPC centers use what's called a module system, and one of the versions of modules redirects everything to standard error. So if you needed to search through stuff like that, you'd have to redirect it, for example. And to do that, you just do that. Something prints out the standard error, you do this 2 greater than sign ampersand 1. That directs it to standard output, and then you can run stuff on it like grep or other commands. If you want to put the output of a file of a program into a file, you just do this like greater than sign. So like my program greater than sign file will save all the outputs to a file. I'll show an example of that in a little bit. If you use 2 greater than signs, it will just concatenate to the same file. So that can be kind of useful if like you're doing multiple runs or something and you just want it to be on the same file. If you do a less than symbol, like program less than symbol of file, it will put the contents of whatever that file is into the input of the program. I'll have an example of that as well. Finally, there's this pipe. This basically just redirects output, so you can kind of basically chain commands together. Kind of a classic one back in the day was you'd cat a file, print out everything in the file, pipe, grep, and then search for something in it. And then so you can kind of chain a bunch of commands together if you want. So if you get really good with the bash shell, there's a whole lot you can do with just pure bash. When you're in a command line interface, sometimes you need a text editor. The kind of big 3 that will mostly be on systems are Nano, which is kind of the easiest to use, VI or Vim, and Emacs are kind of both power user text editors. There's a lot of others. If you're just new to Linux or the command line, I recommend using Nano. Otherwise, the other ones might be a little overwhelming. And finally, we're going to talk about shell scripts. So the shell is basically just a command interpreter. So it kind of handles how you, like how the output of a program kind of runs in its shell. It handles setting these environment variables and just stuff like that. And as mentioned before, multiple shells are available on Linux distros, and all my examples are going to be in Bash. And just before we get into some of the more complicated or some of the more in-depth Bash scripting, one of the big ones that's really useful to know is just doing a basic loop. So if you need to run a command multiple times, this is basically what it looks like. If you have a hashtag or number symbol in front of something, it usually means it's a comment. If you're doing a loop, it's for something, for I in this list of files, for something like that. Do you that just is a command that says, hey, yep, I'm in a loop. You put whatever your work is in the middle of this, and then just a done to say, yep, my loop's over. And then, yeah, just a couple of other resources that are pretty useful. If you want a little bit of self-directed learning of kind of using the shell and all that, I really recommend the software carpentry lessons. They're pretty in-depth about using the shell and then going into kind of basic Python, basic other programs and stuff like that. And then the data carpentry is pretty similar to the software carpentry, but focuses on specific data sciences, and also using R for genomics and stuff like that. And with that, I will get into some of the examples. Stop sharing for a quick second, and if there are any questions, now's a good time as well.
So, Kevin, one quick question from my side. So, what is the difference between using Linux on Chinook and on our computer? I mean, what version do you use on Chinook?
Oh,
What
gotcha.
type of Linux? And what are the pros actually? Do I need to install the software or is it already there or something?
Okay, yeah. So the version of Linux we use on Chinook is Rocky Linux 8. Um, And kind of one of the advantages of using kind of a shared system is that we do try to install a lot of basic software that users will need. So we install multiple compilers. We make sure that the like CUDA for like the GPUs and the NVIDIA drivers are kind of up to date. Um, Tend to have multiple versions of MATLAB and things like that. Kind of the downside to like of the version on Chinook and stuff, we are on Rocky 8. Rocky 10 is out, for example, so we don't keep on top of the latest distributions. We always stay on a supported distribution, but it might not be the latest. What that kind of means for you all is you might run into what certain library issues. The big one is glibc. That tends to be only upgraded when you kind of go to other major Linux versions. So Rocky 8, Rocky 9, Rocky 10 kind of have a different set of these kind of like core libraries. So if you're using like really modern stuff, or if you're familiar with Mamba, Conda, stuff like that, sometimes those programs and stuff were built on too new a version of Linux that run on kind of a lot of HPC clusters, and usually, so you might have to keep that in mind. The other kind of big difference, as I mentioned a little bit, when you're on our systems, you don't have um, admin privileges. So if you need to install software yourself, you usually need to figure out how to build it um, in your own home directory or in the file systems that you have access to. Most HPC centers, including RCS, we're very happy to help you with that process. Um, but that's just kind of one of the other downsides. Because I know a lot of tutorials for setting up like PyTorch or setting up a lot of these AI things assume you have admin access to your machine. Oh, other thing too is a lot of on these shared systems, you usually have to be a little more aware that you're on a shared system. So if you start doing like stuff that takes a lot of heavy processing, most centers will send you a polite email asking you to move it to a more appropriate like compute node or something, because everyone is logged in at the same time. So you might affect other people's work. All right, let me share my screen real quick. think that's good. All right, so I am on just a Linux system. Gonna just run through some commands, talk a little bit about some like bash scripting a little bit, and kind of go over some of the commands that we very briefly talked about.
Can you zoom a little?
Oh, zoom. Is that better?
Comment plus, yeah. Yeah.
Okay. Maybe I can just also full screen it too. It might also help. All right, so if I just do a print working directory, I'm in /home workshop. You can do an ls to see what's around. I have a CLI directory. Talking about flags, I can do the ls-a, and you'll see that I have like a bash history, bash profile, bash rc. I'm going to use VI for most of my examples when I'm like opening files. You can use Nano or anything that you like. I'm old, so I use Vim. This is kind of what a bash RC looks like. You can see a couple of things where it like sets your path to some kind of default values and things like that. But if I really wanted to, I could change this. So if I want my path to be home.localbin.bin, and then I can do see if I remember the exact one. I think it is scripts. You can see that each directory is separated by a colon. So this should, if I have my directory name correct, find a couple of scripts that I wrote as well. And then if I really wanted to, I could also like set an environment variable here equals. And so I'm actually going to have to log in and back out again because the bash RC is read in when you log in. You can also kind of reset it, but this is just probably the easiest way to do it. And so now if I echo my path, so I do $name for the environment variable, you'll see that my change was added. If I do like echo workshop, it'll say workshop variable. Then I think I did input.py. Yeah, input.py is a Python script that I wrote just as an example. I do which that, it will tell me where it is. So the switch command, as I mentioned a little bit earlier, is really useful on shared systems because, for example, on Chinook, we have, I think, 3 or 4 different versions of MATLAB installed. And so if you're running into something, you might need to check what version of MATLAB you're running. And doing like which MATLAB will tell you the path and or path show what year it is. So I'm going to change directory to the CLI directory, pwd, there I am. And you can see I'm using a relative path here. I didn't type out the full thing. If I wanted to, I can go to the root directory. We'll see that I'm in the root. You'll see my homes there. And then if I wanted to do an absolute path, I could do cd/home workshop CLI, and that also gets me back. I have a bunch of different directories here. They're all for kind of some different examples. We'll start with this ebooks directory. So I downloaded a few ebooks from Project Gutenberg just as an example. So if like I was interested in seeing maybe what the titles were of these books, because if I look at one of these, all I'm getting is a number and then it's a text file. So if I wanted to see what the beginning looked like, I could do, head this, and it will print out some number of lines. At this point, it's not super useful. It's a lot of the boilerplate, but it does tell me that this book is apparently the book of household management. If I wanted to put in like more lines for the head command, I could put in like, I don't know, 30 or something, and it will print out more. And then you can see, oh, there's a title here. If I was kind of interested in maybe seeing what all the titles were here. I could use the grep command. So I could do like grep title. If you put stuff in quotes, it will try to match exactly. And I may or may not escape characters. I can never remember if it does or not. And then I can use star. Actually, yeah, just star. Dot star will do, which will look at all the files in here. Should at least. Let's just do star. And it'll try to look for this title phrase. And then you can see that these are the lists of books that I have in here. So using grep can be really powerful. If you're like either working with data you might not know everything about, or if like you have logs, like you might have a program that's misbehaving and has something in the log, you might want to be able to grep and look through like for errors or something like that. See in here? Oh. And then I think just because we talked about it, tail works basically the exact same way as um, the head command, except it just prints stuff at the bottom. And you can do the same -n flag for increasing the number of lines to tail. And if I really wanted to, I could do cat, and then I'm going to pass this to the less command, which will just let me scroll through it. Because otherwise, if you just do cat, it will just print out everything to your terminal. If I wanted to do some redirection, I can say, hey, grep title, and then I can do like title.titles.txt. You'll see that it didn't print anything out to the screen, but it did create this titles file, and it just spits out what the output is. So this can be useful for some of your data files sometimes, if you need to like create an index, or if you're looking for stuff from a particular year or something like that. You can do an ls-l. This is the long listing of what these files are. You can see my permissions here. First three are, well, the first one is if it's a directory or not. I'll show that in a second. Otherwise, it's read, write, execute, read, write, execute for the user, read, write, execute for the group, and read, write, execute for the other. And then you can see when I did my like titles, it created that the same. If I wanted to change what my default behavior is, I can do say 0002. So when I do that, and then let's do my grep again and call this titles missions and do an ls-l, you'll see that this file, this now has read write for my group because I changed my umask. And if I wanted to change it manually, I can do the chmod. You do either U, G, or O for user group or other. And then you do plus or minus for either adding permissions or removing permissions. And I'm just going to move right from titles permissions. And when I do my ls-l again, you'll see that it's no longer has write permission. So when you're writing like your scripts on like an HPC cluster or something like that, and you say need to share your results with your group, I'd either recommend setting a umask to add, read, write, potentially execute at the start of your script, or at the bottom, just run some chmod commands just to make sure that everybody can access the files. It just makes it a little bit easier.
Just snooze it.
Okay, just use it. All right. All right. So let's see. Oh, let me do this too. Let me increase the size here. So I'm on my local machine now, and on the VPN. Let me do this real quick. The Linux machine that I'm running all of this on is behind a firewall, so I need to jump on the VPN to be able to access it. just do that real quick. All right, so I am on this machine. I'm in a downloads file. Let's say that I want to like copy the CSV over. Do an SCP file name, and then basically the destinations. I'm going to do my username on this machine at you, and then the directory that you want it to be in. CLI loads. And then it should ask for my password. And you can see that I copied over. You can see that I have this like test directory that I created before. You can see that it has this D in front of it that says it's a directory. Let me just remove these files. So if I'm doing the RM command, I can do RM star. It will ask me, Z shell will be nice and ask me if I really want to delete these files. Some Linux ones will just delete everything by default. So if you're running any sort of remove command with a wildcard in it, just be a little careful about what you're actually deleting. Let's do a little bit of a loop here just to show an example of that. Basically, the seek command just prints out 10 characters. I'm saying, hey, for I in each of these numbers, do a thing. I'm going to use the touch command, which just creates a file. And I can sub in this I as an environment variable. And I'll show another example of this that's a little bit more interesting. And then I do the done, and you can see that I created 10 files. The reason I'm doing this is I just wanted to show off the rsync command. Basically, I have this downloads directory. I have another downloads directory on my workshop computer, and we'll see if I have my slashes right. But basically, I'm going to try to keep these directories in sync. And you can see that it transferred some stuff. It said it didn't transfer anything, and I suspect that's because it downloads. Oh. All right, so it did not have the. Okay. Oh, that's what happened. I was one directory up. So here I'm using a relative path, and since I was using a relative path, there was no downloads in my downloads directory. I'm going to do it this time. You can see that it sent over this precipitation file, a test directory, and all these files in the test directory. And when I go back here and do an ls, you'll see this test directory now exists and my files. So doing the rsync is pretty useful if you're trying to like, if you have a data set on one machine and then you're trying to copy it over to say an HPC cluster, you can do the rsync command and it will copy over like any changes, anything new. But if all the data is already there, like for example, if I run this again, it'll probably say that I'm transferring stuff, but you can see that it didn't send as much data over because all it was doing was sending kind of some checksums over to make sure the files were the same. All right.
So I have a question on rsync. So does rsync work like if you make some change in the file, and if you would like to do the rsync, does it remove the original file in the destination and copy the newly modified file, or?
Yeah, so if you do an rsync, so like I change a file on like my laptop and then do an rsync with that destination file, yeah, it'll move the new file, the modified file over to the destination.
So an entire thing. You can just close it.
Yeah, but it won't do the opposite. So if I had changed the file like in the destination, I'd have to rsync it back.
Okay, I see.
All right, so I have a little scripts directory here. We'll start with the most basic script here, which is just all this script does is sleep for 5 seconds. You'll see this hashtag #, exclamation point, bin bash that tells the shell that, hey, this is a bash script. Run this with bash if you're running it as an executable. So for example, let me So I removed the execute bit from this. So if I try to like run this, it says permissions denied because there's no executable, but I could run it as bash sleep.sh. You can see that it started. It's going to wait like 5 seconds asleep, and then run. So if I remove this, we'll see how this works actually. I don't know how bash is going to handle this. So I added executable back in. And so if I try to run it, bash knows that it's a bash script, but if this was something like Python, it would probably fail. But we're going to add that back in. And then I'm just going to add this as like 500 just to show if I wanted to run this in the background. So, you notice if I run sleep.sh, I'm stuck here. I can't run any other commands. Nothing's going to happen because it's going through its loop. I have to cancel it with the Control C. That's kind of another handy thing to know. If you're running something and you think that it failed, or you didn't mean to run it, you can always use 90% of the time you can Control C and kill it unless something's gotten a real bad state. But say this was a script that was actually doing something and I wanted to be able to run some other stuff in the background at the same time. I could run /sleep.sh ampersand. And then you'll see like it started to write stuff, but then I can actually still write stuff. I can, look at the script. If I modify this script, it will not affect the one that's already currently running because it's loaded itself into memory. And if I do like a PS though, you can see that my script is running. And if for whatever reason I wanted to run this sleep script interactively again, I could just do FG this and huh. Well, FG command. I thought you're supposed to press the PID, but I can hit the help pages later. Doing the FG will bring it back, and then unfortunately I'm stuck again. But this can be useful if you're running on an HPC system and say you have the big one that we've seen is some people have some R code that isn't written with parallelization in mind. Like it just runs on a set of data sequentially. If they want to run this on like 24 sets of data, using this background functionality allows them to run 24 versions of the 24 copies of their script on 24 different sets of data. In the HPC intro lecture, we'll talk about that. Let's see. So I have this input.py script. It's just a really simply written Python program. All it does is asks for some input in a loop, and we'll keep asking for input and print it out. If I wanted to redirect something into it, I could do something like this. Basically, I am going to print out whatever is in this sleep.sh. That's what the cat command does, and take that output and redirect it into this input.py. Actually, I guess it actually looks for a file for the file redirection. And you can see that the input was what was in my sleep.sh script. This can kind of be useful. Certain programs just expect you to pass it a file. Sometimes it'll be a flag. Other times they'll use this redirection. And then if I wanted to just, for whatever reason, copy a file, I could do like copy parse by year .sh. And if I cat that and then cat copy, you'll see that they're the same script. Again, this is more useful for kind of output or error logs if you're looking for something like that. And then finally, I have a couple of simple scripts to sort of look at and kind of show why using shell scripting and using the command line can be a little bit more useful than like having to input a GUI or doing all this stuff by just typing out a bunch of commands. So to start off with, I have this parse by year command. Basically, all this script does is it will parse the CSV file, output the year and data into a file called station_year, and create some files. And so I'm just using some basic bash commands to do this. I'm using grep to grab the station name. I use this command called awk to split up a line, print some stuff out, and use tr to trim some white space from it. And I'll show why that needs to happen in a little bit. So that creates the station environment variable. And then after that, I grep for the year, because I'm passing some arguments to this script of some data that then trims it and then basically puts all the data from a single year into a CSV file. And station data. This is going to be what my files look like. So basically, data where it was downloaded from, a station name, station ID, when it was downloaded, and then this is just the date, max temperature, mean temperature, and minimum temperature, going from 2000, and then if I go to the very bottom to 2025. So I could, open the file, copy all the 2020 data with like in a text editor, copy it, paste it to a file, move on to 2001, etc. That would take a while. Or I can start off with just use this parse by year. Say I'm looking for, well, first off, it'll show what the usage is, and then it tries to grep something and can't because there's no arguments to it. So let's say I want all of 2000 and then station data, and we're going to just start with whatever this first file is, station 25309. And then, so looks like it did something. If I look at the yearly data, let me delete all this. To show exactly what it was doing. So I was looking at the yearly data. Now see I have Juno 2000. So I have all the data for the year 2000 for Juno in a CSV file. So let's say that I want to do this for all the stations that we have for all the years of data that we have. I could, manually run this command, changing 2000 to 2001, doing the station file, incrementing all the way up to 2025, and then switch the station file, repeat. Or I can create, I'm trying to do this on the fly, a little loop. I'm going to say 2000 to 2025, do parse by year, doing the year here, and we'll just do one single station first. Because I think I have a longer example in a second. So this will get basically all the file, all the Juno data from 2000 to 2025 in a single command. So that just kind of makes it really useful to, speed up my processing. I don't need to manually do this. And then say if I wanted to do, say I needed to gather these files like every month or something, like, this temperature data isn't going to change. But say it's some like genomics data or some wildfire data that is constantly changing and I needed to run this, I could create like a whole workflow script that does something. And in this case, basically, I take all the years, look at all the station files, run the parse on it, and then I have this kind of summarized script that basically just prints the highs and lows. And I can just run this workflow script and it'll kind of chunk through, and then you can see that it's printing out a whole bunch of data for each of these files that it creates, where it does like the average temperature for the month, the high, highest, and the low. So using shell scripting, it can be really powerful in being able to like duplicate what you've done. You don't need to remember exactly, what you typed in a month ago. On the HPC systems, everything is expected to be a kind of shell script when you submit it to what's called the job scheduler. So knowing a little bit of Bash will really speed up that process of really running your applications and your analyses on the HPC system. But I think that's most of what I had for this kind of intro to Linux. I don't know if there's anything you thought should be covered or any questions.
One thing I would like to know, so if I would like to schedule some script to run
Oh,
again and again, so is there any utility or anything you could
yes. Usually you use the cron command. And this is where I'm going to recommend. There is a site that's called, I think it's crontab.guru, is what I usually recommend. I can share this real quick. Let me just share my whole screen for a second. Just okay.
Oh, okay.
Yeah. So cron tabs have this kind of format of what minute, hour, day, month, weekday you want to run something at. It can be really hard to remember what this format is. I forget it constantly. But if you do a crontab-e on a system, and certain centers may be more or less strict about setting up a cron tab on a shared system. Generally, as long as you're not doing anything process intensive, RCS doesn't care too much. Like if you're just doing something that like checks some files, or you need to download files every day, that's perfectly fine. So let me shrink this a little bit. So if I want to do like a cron tab and say, I don't know, I want to run this every day at, I don't know, what's 11:15, so 15, 11. We'll do this, just copy. And then if I go back here and do a cron tab, and just say, let's see if I can type this fast enough before it hits 11:15. CLI, percentage. Okay, and hopefully we'll see if that worked in about the next minute or so. But that can be one way of doing it. So if you need to run it every day at a certain time, we have some users who do it when they have either like they know they're gonna have a process they need to kick off at a certain time. They'll use like a cron tab, or I'm assuming a lot of the people who get satellite data probably have some cron tabs set up. All right, we see we have an example.txt. We will see if there's anything in it. Okay. Let's see. I probably messed up, but we can see that it created the file. But you can use a cron tab. This does it just for your own account. And yeah, these tend to be wildcards. So if you want to run it like every day, month, year, etc., that's where you put these. Putting the wildcards in minute and hours, I would not recommend, because I think that would try to run it like either every hour or every minute. That people will notice. But that's another kind of powerful tool to keep in mind.
Great. Yeah, I mean that website was really Nice, actually.
Yeah.
Okay.
Oh, I guess I can also show off UMass calculator as well.
Okay.
If you're trying to do, there's a whole bunch of them out there. I don't know which one is great, but basically, if this one will say like, hey, I have a file that has read write for group. This is that octal format I said that is awful. And then if I want to do like a mask of read, write, and execute for user and group, it tells me to use 007. Both of those can be kind of useful. All right. So I think that is everything that I have. So
Great.
if there's any other questions or anything, always feel free to email me or
And any question from the Zoom participants or anyone? All right. And so thanks, Kevin. One quick announcement. So we every alternative week when we do not have any when we do not really have any presentation, we are actually hosting an office hour. So I will be there. So if you have any issues that you would like to discuss with us, please feel free to chime in the same Zoom link, and I will be happy to help if you need anything. So for example, like today is February 10, Kevin did the lecture. Next week means February 17, there is no lecture scheduled, but there will be an office hours where I will be present. If you have anything to discuss, you can discuss with us. And with that, our next webinar lecture will be on February 24, and that will be by myself. And we will be discussing Python and beginner's intro to programming, scripting, and some introduction of vibe coding and all these things. So with that, we are concluding here today. Thanks a lot, Kevin.
Yeah, no problem.
And for any question, yeah, feel free to send an email to either of us, either myself or Kevin, and we'll be happy to help. Okay, thank you.